So here's some application problems. Here we're just looking at graphs. So we have a graph of two runners, and the graph is distance versus time graph, and runner A and B, A in the pink and B in the blue, and they're running a 100-meter race. So it looks like they finish at the exact same time and start at the exact same time. So at what time is velocity the same? Okay, so velocity would represent the slope. Since A is going at a constant rate, their slope is the same. And for B then, it looks like probably about 10 seconds. Looks like we have a tangent slope about there. So approximately, we're going to say approximately at 10 seconds. So it says here, at what time is the velocity, the distance between the runners, the greatest? Okay, well, how are we going to do this? Well, if we kind of take a look at the very beginning, they're close. At the very end, they're close. Okay, so the distance between it, and it looks like kind of somewhere in here, they're going to have the greatest distance between them, somewhere in there. Okay, now, if we were to guess, maybe it seems that where the velocities are equal, that might have something to do with the problem, because it looks like it could possibly be the greatest distance between the points is going to be there. So visually this seems to make sense, but how can we justify this? Well, we can justify this with the relative velocities between the two. So the relative velocity between A and B, okay, so I'm going to call this the relative velocity. Okay, and we'll just do A minus B. Okay, so relative velocity of A minus, we're going to do, we'll do A minus B. It doesn't really matter. So relative velocity for A minus B for t is greater than 0 seconds and less than 10 seconds. The relative velocity is going to be positive. Okay, so our A value is going to be positive. A is positive. Okay, and then from 10 to, looks like they finish at 14 seconds, the velocity of B is faster, okay, because B is smaller up to here, the equivalent, and B is always increasing, so B's velocity, from this point on, the slope of B is greater than slope of A, so we're going to say that B is positive. Okay, so the distance between them, where they're going to be, maybe I'm going to write this way, so it's going to be A is negative. Okay, so the distance between them should be at the point where the velocity between them is at maximum, and the velocity between them, or the relative velocity between them, is going to be equal to 0. So the relative velocity, if we sketch the relative velocity, okay, so the relative velocity between the two is going to be from 0 to 10. A is going to be positive. Okay. A is going to be positive and B is going to be negative at that point, at 10 seconds. And if we were to plot a distance time graph for that, we know that it's going to look like this. So the relative distance, and I'll write this as relative distance, is going to be maximum at t equals 10. So that would be what the graph, this is relative velocity, that's the relative distance. So we can justify that the distances are going to be the greatest. The greatest distance is at t equals 10. So the greatest at t equals 10 seconds. Okay, and so visually it looks like the case. We could also justify it by looking at the relative velocities, where the relative velocity is 0, that's going to give us our maximum distance.